We're just looking at a GCF. Okay, what is the greatest common factor? What do they have in common? So if we look at example number 1 there, we look at the numbers first. Okay, 12 and 10. 12 and 10. What is their greatest common factor? 2, right? That's the biggest number that will divide evenly into both of them. Now let's look at the variables. The 12 has 3 A's. The 10 has 2 A's. So the most that they have in common are 2 A's. So A squared, 2A squared is our greatest common factor here. Now, if you struggle with figuring out what goes in the parentheses, look at it this way. You're dividing your terms by the greatest common factor and putting the result in your parentheses. 12 divided by 2 is 6. A cubed over A squared is A. Bring down that plus. 10 divided by 2 is 5. A squared divided by A squared, it goes away. Okay, so that is it. You can always check your factoring by multiplying it back out. 2A squared times 6A. 2 times 6 is 12. A squared times A is A cubed. 2 times 5 is 10. And then it has an A squared on the end of it. Okay, let's look at number 2. 14 and 7. Their greatest common factor is 7. 14 has 8 M's. 7 has 2 M's. So they both have 2 M's in common, M squared. 14 has 5 N's, and 7 has 2 N's, so that's N squared. Okay, 7M squared, N squared is our GCF. So if we go and divide both our terms by 7M squared, N squared, 14 divided by 7 is 2. When you divide with the exponents, you subtract them. So that's M to the 6th. 8 minus 2 is 6. 5 minus 2 is 3. So that's N cubed. Minus 7 divided by 7 is 1. M squared over M squared, it's gone. N squared over N squared, it's gone. You have to have that 1. If you don't have the 1, when you go to multiply it back out, you're only going to get that first term. You're not going to get the 7M squared N squared that you're supposed to have there on the end. Okay, so that is just factoring out a GCF. You always, always, always look to see if they have anything in common first. Now let's talk about the first case that we are going to go over, the difference of perfect squares. So let's list our perfect squares. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. I could keep going. That's probably as far as most of your problems, that's about as far as you're going to go. Okay, but you could keep doing the list. 13 squared, 14 squared, 15 squared, etc., etc., etc. Those are what we consider our perfect squares. Here's the rule. If you factor the difference of perfect squares, it is always going to be A plus B times A minus B. Okay, the A comes from, well, what do I square to get the first number? The B comes from, what do I square to get the second number? Okay, there must be a minus sign in between. That must be a minus sign. Okay, so let's look at factoring number 3. Do 9 and 49 have a common factor? Are they both evenly divisible by the same number? No. Okay, I'll go ahead and answer that one for you. X squared, Y squared, they don't have anything in common. So we do not have a GCF here. Next question we need to ask is, are 9 and 49 perfect squares? Are they in our list that we listed up here? Yes, they are. Okay, now this will help some people. Some people can just see it. So if it helps you, write it down. I'm going to rewrite that as 3x squared, because 3 squared is 9, x squared is, of course, x squared. I'm going to do the same thing with 49. 7 squared is 49, so I'm going to rewrite that as 7y squared. The reason why I did that was because of what's in this box right over here. Okay, it says a squared minus b squared. I figured out what a and b are. A is 3x, b is 7y. So I can plug that into the rule. My rule says it's a plus b, so 3x plus 7y times 3x minus 7y. One is always going to be positive, one is always going to be negative. One's going to have a plus, one's going to have a minus. But they're always going to be the same numbers. Check it. You can always check your factoring. Multiply it back out. 3x times 3x is 9x squared. The outside, 3x times negative 7y. Let me do this over to the side here. We get 9x squared. 3x times negative 7y is negative 21xy. The inside two terms, positive 7y times 3x is positive 21xy. And then the last two terms, positive 7 times negative 7 is negative 49. Y times y is y squared. Well, those 21xy's cancel. And what did we end up with? What we started with. Okay, you can always, always, always check your factoring by multiplying it back out. Or, if you have multiple choice answer choices, multiply out the answer choices and see which one gives you that original expression. Okay, number 4. Are 72 and 2 on our list of perfect squares? No. Do they have something in common? Yes, they're both even, so we need to factor out that 2. If we divide these by 2, what do we get? We get 36c to the 4th minus 1. You can't leave off the minus 1. You gotta have that. Now, are 36 and 1 perfect squares? Yes, they are on our list. So, let's rewrite those. 6 squared is 36. C squared is c to the 4th. Because what do? When you raise a power to a power, you multiply. Power to a power, you multiply. So 2 times 2 is 4. So 6 squared is 36. C squared, 2 times 2 is 4. And obviously 1 squared is 1. So this is our A, this is our B. We gotta keep that 2 in front. If you have a GCF, you gotta bring it down. You can't just leave it out. So we've got 6c squared plus 1 times 6c squared minus 1. Now, before you say that's your final answer, you got to check and make sure that you didn't miss anything. Okay? Inside of our parentheses, 6 and 1, they don't have a common factor other than 1, so we're good there. Here, with the minus sign in between, you got to make sure that 6 and 1 are not perfect squares. 1's a perfect square, 6 is not. So we're finished with that one. Okay, that's as far as that one will factor right there. Okay, let's look at number 5. 7 and 28 are not perfect squares, but they do have a factor of 7 in common. We've got 7 m's and 1 m, so 1 m is a part of our GCF. We've got n here, 3 n's there, so n is a part of our GCF. So if we divide by 7m n, I wish they wouldn't use those two variables together. I get tongue-tied. 7 divided by 7 is 1. M to the 7th over m is m to the 6th. N over n cancels. Minus 28